smashed into Jupiter. The impact's blast was so powerful that it unleashed a force equivalent to 300 million atom bombs. For 6 days, Jupiter was throttled by 21 separate impacts from the comet's fragments, which produced giant plumes of debris that rose 3,000 kilometers above the cloud tops, an impressive feat considering Jupiter's immense gravity, and heated Jupiter's atmosphere to temperatures reaching 30,000 degrees Celsius. At the moment of impact, the comet was traveling at a blistering speed of 216,000 kilometers per hour, with its largest fragment spanning 2 kilometers in diameter. The impact raised huge clouds of debris that were visible for months and left a scar in Jupiter's atmosphere more prominent than its great red spot. Now, collisions of this magnitude aren't entirely unheard of. Our solar system is littered with evidence of major impacts from comets and asteroids. Scientists believe Earth was hit by a massive asteroid at the end of the Cretaceous period, which likely led to the extinction of the non-avian dinosaurs. But these events are extremely rare, meaning the chance to see one in action is a once-in-a-lifetime opportunity. So, what did it look like? And does the incident shed light on the odds of a similar event happening here on Earth? I'm Alex McColgan and you're watching Astrum. Join me today as we relive the biggest planetary explosion ever witnessed from space and unpack what it taught us about Jupiter and planetary collisions. In 1993, astronomers Carolyn and Eugene Shoemaker and David Levy were conducting research at California's Palomar Observatory when they discovered a periodic comet that had been captured by Jupiter's gravitational pull. Periodic means that the comet has an orbital period of fewer than 200 years. This was unusual, as most comets in the solar system orbit the Sun. However, Jupiter is so massive, being the largest of the 8 planets by far, that its ability to capture other objects approaching its orbit isn't surprising. A lot of Jupiter's irregular moons are likely captured asteroids and comets that have since burned off their volatile material on their surfaces. But this comet also had other unusual characteristics. For one, it was big. So big that scientists think that the frequency of similar impacts is a 1 in 6,000 year occurrence. But the comet was also fragmented, most likely torn apart by Jupiter's tidal forces on a previous approach. Most striking of all, however, was its highly eccentric orbit. Eccentricity measures the deviation of an orbit from a circle, with 0 being the value of a perfect circle and 1 being the upper limit of when an elliptical orbit becomes hyperbolic. Shoemaker-Levy 9's orbit had an eccentricity of over 0.998, in other words, extremely eccentric. Almost immediately, astronomers realized there was a possibility the comet would collide with Jupiter, but their suspicion turned into certainty once they collected more precise data. Before long, astronomers knew the impact would occur sometime in July 1994, and pretty soon the whole world was waiting for the event with bated breath. Anticipating SL9's impact, astronomers monitored its movements from the Keck Observatory, Germany's Rosat X-ray telescope, and NASA's Hubble Space Telescope, among other instruments. But when the first of the comet's fragments hit on July 16, 1994, the worst-case scenario occurred. It looked like we would miss the spectacle. You see, SL9's trajectory meant the impact would occur on the side of Jupiter facing away from us. That meant none of Earth's high-powered telescopes were in position to view the initial impact. For scientists, this would have been a crushing disappointment. But as luck would have it, not all our cameras were located here on Earth. By sheer chance, NASA's Galileo spacecraft, launched in 1989, was only 1 year out from Jupiter at the time of SL9's final approach. It just so happened to be in a perfect position to record the impact as it happened. But Galileo wasn't our only helper from afar. The Ulysses spacecraft, which had been launched in 1990 to monitor the Sun, was also pointed at Jupiter. And even NASA's Voyager 2, located 44 astronomical units away, was programmed to monitor radio emissions from the crash site with its ultraviolet spectrometer. Each probe paused its own missions to work together on this to help us witness an extraordinary event. Shortly after Fragment A impacted Jupiter, Galileo saw a massive fireball erupt, reaching as high as 24,000 degrees Celsius. Its plume quickly rose 3,000 kilometers, which would make it as big as Australia from north to south. This was surprising, as scientists hadn't expected to see fireballs in the aftermath of the collision. A few minutes later, masses of ejected debris plummeted back towards Jupiter's surface and burned up, again turning Jupiter's atmosphere into a raging furnace. Before long, Jupiter's rotation brought the impact site into view of Earth, allowing high-powered telescopes like Hubble to view a huge dark spot on Jupiter. As it happens, Jupiter's rotation is fast, with days that last only 10 hours. Contrary to what you might think, larger planets tend to have shorter days than smaller ones. The comet's impact set off shock waves, which rippled across Jupiter's dense atmosphere at the speed of 450 meters per second. And all this was just from the first impact. For 6 days, between July 16th and July 22nd, the comet's fragments bombarded Jupiter, the largest coming on July 18th when fragment G hit. Its impact alone produced a blast 600 times more powerful than the world's entire nuclear arsenal, leaving a huge dark spot 1 Earth diameter across. However, as spectacular as the initial impact was, the comet's aftermath proved just as valuable. By studying the clouds of debris, scientists gained an unprecedented window into Jupiter's atmosphere and its movements. In addition, they caught a never-before-seen glimpse of Jupiter's composition beneath its dense cloud tops, as spectroscopic readings were able to identify material that had been splashed upward by the comet's impact. They detected diatomic sulfur and carbon disulfide, and heavy elements like silicon, iron, and magnesium. Interestingly, they also detected substantial amounts of water, something they weren't necessarily expecting. In fact, one of NASA's Juno probe's primary objectives is to locate where this water is hiding in Jupiter's atmosphere. However, one of the more disturbing implications of the impact was the realization that large celestial bodies could still hit planets. One school of thought theorized that major comet and asteroid collisions had been a lot more frequent earlier in the solar system's existence, but Shoemaker-Levy 9 made it clear that very destructive collisions were still possible. Had it happened by chance and we witnessed an extremely rare event, or does it happen more than we thought? Remember, we've only had the technology to see this kind of event within the last 80 or so years. If a comet as large as SL9 were to crash here on Earth, it would lead to the extinction of most life on the planet. This had a dramatic effect on our collective psyche. As anyone who lived through the 90s can attest, it was also a wake-up call for NASA and for various defense agencies. Before SL9, the term planetary defense didn't exist, but in its wake, NASA took up the mission of monitoring near-Earth objects, or NEOs, with the goal of identifying upwards of 90% of asteroids in our celestial neighborhood greater than 1 kilometer in diameter. Having achieved this goal, NASA is now well on its way toward identifying asteroids greater than 140 meters. But before you stay up all night worrying, be aware that these events are undoubtedly rare. And there is perhaps one other silver lining to SL9's impact. You see, Jupiter is a massive planet with a powerful gravitational influence, and since it is also one of the outer planets, some scientists now think it might act as a cosmic vacuum cleaner of sorts. We know that Jupiter gets approximately 2,000 to 8,000 times as many cometary impacts as Earth. So, perhaps one of the reasons extinction-level impacts are so uncommon here on Earth is that Jupiter had been a magnet for these kinds of comets and asteroids. This argument has even become part of the rare Earth hypothesis, which suggests that Earth is host to a unique set of conditions without which the evolution of complex life would be impossible. Not everyone agrees with this hypothesis though, and in any event, we're still a long way from proving it. So, while we might not know the exact likelihood of a massive comet or asteroid hitting the Earth, the impact of SL9 with Jupiter has certainly advanced our understanding of these events. Moreover, it was, without question, a spectacular moment that treated watchers to one of the most impressive action scenes ever witnessed by human eyes. Maybe one day we'll have the chance to see something bigger, but hopefully from not too close. While there have been other explosive events, like the 2022 Tonga volcanic eruption, for now, the winner is clear. The biggest explosion ever seen on a planet is Shoemaker Levy 9, and by comparison, the competition looks like a drop in the bucket. When I'm researching my videos, having a good search engine is vital. I was really impressed with Neeva, a search engine extension that you can add to your web browser that doesn't have ads and completely protects your privacy. It was so refreshing not having to scroll through multiple paid-for results before I could find the actual results I needed. With Neeva's simple-to-use features, I could even customize searches. It was easy to say "see more" to some web pages or "see less" to others, which I found really cool. And best of all, thanks to built-in tracker blocking, none of my data was recorded, meaning the results I got were the best ones for me, not the best ones for companies. While Neeva is free to use, if you use my link in the description, you can get a 1-month free trial of Neeva Premium, which offers you unlimited searches, new features, and Bitdefender VPN plus LastPass Premium for even more protection. So go check it out. Thanks for watching. If you enjoyed this video, check out my other comic videos in the playlist here. And thanks to my patrons and members. If you want to support the channel too, check the links below. All the best, and see you next time.